Hello, so I'm a little bit late on this one, but Olima also submitted to me a Sudoku in honor of Claudia, who passed away a little bit ago. So I did a puzzle right away by pause for Claudia, and so I figured I'd do a video for this one when I got some time, and things have been very hectic recently, so I think I finally can sit down and record this solve. Hopefully it goes well. All right, so let's go over the rules. It's called For Claudia. It's by Olima. We have normal Sudoku rules. That means in every row, every column, and every box, we are placing the digits 1 to 9 exactly once each. We also have arrows in the grid. So digits on an arrow sum to the value in the attached circle. So if this was, say, 2 and 4, they add to 6. We put a 6 in the circle. If you have multiple arrows coming out of a circle, then those all sum to whatever the circle's value is. We aren't adding all of these, like we wouldn't be able to. But we aren't adding all of these to get the circle value. Instead, this adds to the same as this, which adds to the same as this, etc. And that's all filled in this circle. Okay, so we also have these green lines in the grid. They're kind of faded, a little bit hard to see, but these are green lines. It does look like they go through this cell as well. That's covered by the circle. So the green lines, adjacent digits on a green line have to differ by at least 5. These are called German whisper lines. So if I put, say, a 9 here, then this cell needs to be at least 5 away from 9. So it could be a 4, it could be a 3, it could be a 2, it could be a 1. I mean, other than what the arrow's saying. But by the German whisper standards, this would be okay. And then from the 1, we need to then add 5. So we could go to, say, 6 if we wanted, or we could go higher, 7, 8, etc. And you just do that as you move around the line. Okay, we have green cells. That's these cells here. These are indexing cells. So whatever digit I put in this cell, say I put a 3 here, then that's telling you where the 4 goes in this column. And specifically, it tells you that the 4 goes in row 3. So we put the 4 there. If this was instead of 7, then that says that the 4 goes in row 7. There could be a 4 here, in which case the 4 goes in row 4 and it's indexing itself. This is similar. This is and the reason it's placing the 4 is because it's in row 4. This is in column 5. These red ones are in column 5. They tell you where the 5 go in that row. So if I put a 3 here, then that's telling you there's a 5 right there. If I put a 7 here, it's telling you there's a 5 right there, because that's column 7. All right, we have black dots. They are a 1 to 2 ratio. So another way to put that is one value is exactly double the other. So if this was, say, a 4, this could be 2, because 4 is double 2, or it could be 8, because 8 is double 4. Not all dots necessarily given. That just means I could have a 2, 4 here. There could be a black dot there, but there doesn't have to be, and there isn't. And that's perfectly fine. All right, so those are the rules. I have provided a link in the description if you'd like to try the puzzle yourself. And I'm going to get started now. Now, the thing is, where do I want to get started? I think there's a few things that are kind of begging to be looked at, but I'm not sure what to look at first. The first is obviously this circle, because it has so many arrows coming out of it. So one thing we can say is we know it's at least 5 just from this row here, because the minimum that these could add to is 1, 2, 3, 4, and that's 10. And if we divide that by 2, that's 5. But I think we run into an issue if we make this a 5. So if we make this a 5, what are we putting here? Because this would be 1, 2, 3, 4, and this would see 1, 2, 3, 4, and 5, and it would have to be a 6 on a 5 arrow. That doesn't work. So it has to actually be bigger than 5. So how do we want to think about this? I think 6 works. Does it? No, because there's only 2. We need 3 ways. Okay, this is how we want to think about it. We need 3 ways to add to this digit. Because whatever way we're adding to the digit this way, that can't go here. And then whatever 2 ways we're adding to the digit, that can't go here, because this cell can't be any of those 4 digits. So I guess just to give the 6 as an example, if we have 1, 5 here and 2, 4 here, this can't be 1, 5 or 2, 4, but those are the only ways to add to 6. I mean, 3, 3 is not possible because it would repeat the 3. Because how would we do 1, 5? This can't be 1 or 5. How would we do 4? This can't be 2 or 4, right? So hopefully that's understandable. So we need 3 ways to add, which means 7 is our minimum. This is 7, 8, or 9. If we were 7, one of these would be 1, 6, one of these would be 2, 5, and one of these would be 3, 4. Now, if this was 2, 5, then actually this cell would have to put the 5 in column 6 or 7. So this would be 6 or 7. So actually, we'd probably do something like, I don't know, 6, 1. 6 would put a 5 here with a 2, and then we'd do like a 3, 4 pair. It'd probably be something like that. But again, we don't have to be 7, but I'm just sort of exploring what this means. I don't know that we can do much more with this. It does mean the 5's over here. Right. So I guess one thing we can say about these 3 digits is they're all placing the 5 somewhere. So one of them will be from 1, 2, 3 to put the 5 in this box. One of them will be from 4, 5, 6 to put the 5 in this box, and one of them will be from 7, 8, 9 to put the 5 in this box. So these are one of these is from 1, 2, 3, and one of these is from 4, 5, 6. We can still reach 9 with 6, 3. But the only way we're getting to 9 is 6, 3. So if this was 6, 3, then that puts a 5 either here or here. And so then we'd have to do 5, 4 on that one. Seems okay. All right, maybe there's somewhere else to look, but this is good info. Okay, 5 in this row is interesting because you can't put a 5 on a black dot. If you were to put a 5 on a black dot, you can't double it to 10, you can't have it to 2.5. So you also can't put a 5 on a German whisper line because how would we add or subtract 5 from it? We'd go to 0 or 10. So 5 in this row is in only one of these two because this does see a German whisper line here. In fact, I probably suspect that olima did not have this draw arrows above lines option on, which actually does make this look a little bit better. That's probably why olima made them transparent. Okay, so let's just do that then. Makes it much more clear what's happening. So 5's in one of these. I don't know. I don't know that there's anything I can do with that. What about 4 and 6? So the reason I bring up 4 and 6 is what happens if I make this a 4? Well, this would be double 9, and that doesn't work. And 6 does the same thing. This would be double 1, because 1 is the only digit that can go with 6, and 9 is the only digit that can go with 4 on a German whisper. So these are not 4, 6. That's not 4, 6. So we can put one of 4, 6 with the 5 over here, but then the other one would need to be in the black dot. But we could just do a 3, 6 and a 2, 4 or 4, 8, and that would work just fine here. Is there some reason we couldn't? I don't see why not. Is there something wrong with like a 3, 6 pair or something? Like row 3 and row 6 for it would place the 4 somewhere? I don't really see that being an issue. I think 3 might be a little problematic to place a 4. But it would work. Like if we placed a 4 here, then we'd have to do double 9 like that. Okay, that we can't do. So okay, which of these cells can be a 3, I guess is the question. This can't be a 3, because we put a 4 there, and this would be double 9. The reason that doesn't work is it puts a 9 on an arrow. If this were a 3, this would be a 4, and this would be double 9. That seems okay. This would be 5. It means this can't be 9, but I don't think it has to be. So 3 there is okay, unfortunately, because I was hoping we would roll out 3 entirely. If this were 3, this would be 4, and this would be double 9, which also seems okay. And then if this were 3, this would be 4, and this would be double 9, and that's not okay. So if we have a 3, it's in one of these, or it joins the 5. Okay, then do we worry about the... Oh, it would be with a 6. That would put a 4 down here. That's okay. 4 would self-reference. I'm thinking about where the 2 would go, but all of that seems okay. So I can't quite roll out 3, 6. If we have a 3 in one of these, then the 6 is over here, puts a 4 in one of these, but that seems okay. I'm a little lost what to do here. This is at least 5, but it can't be 5, so it's from 6, 7, 8, 9. Ah, okay, well that's a good starting point. Should have realized that earlier. The reason for that is we have the same thing going on here. These add to at least 10. 10 over 2 is 5, but we can't actually put a 5 on our German whisper line. So this is high. So I'm actually going to do some high-low coloring here. So I'm going to use orange for high. And then as we move along the whisper line, once you have a high digit, you can't add 5 to it, so you're going to be subtracting 5 from it, and that's going to cross the 5 boundary and put this as a 1, 2, 3, 4. And then this will be high, low, high, low. So this should help think about things just by coloring. So blues are low, oranges are high. Now we know this can't be 6. Oh, no, it was 4 that it couldn't be, but now we definitely can't be 4. So can this still be 3? This can't still be 3 because that would make this high. Ah. No, it puts a 4. That would be fine. Never mind. 3 puts a 4. No, that works just fine. Did I learn anything from this? Oh, okay. So what can we say about black dots? Well, what can we say about black dots? One thing we can say about black dots is that they always have a low. They could have 2 lows, but they never have 0 lows. Because if we had 2 high digits, how would we have one of them be twice the other? It just doesn't work, right? So we need at least 1 low. We could have 2 lows, like a 1, 2 or 2, 4, but we can only have 1. But we already have 2 lows in this row. So this black dot can only contribute 1 low, and this black dot can only contribute 1 low. There's only one way to do that, 3, 6, 4, 8, which is what I was trying to disprove, which is why I couldn't disprove it. So this is not a 6, because these are 3, 6, 4, 8. We know that these aren't the 3s, so these aren't the 6s. I don't know that I can limit 4, 8. But this isn't an 8 either. And then we're left with these being high digits, or 5. One of them's 5. I'm going to use gray for 5. One of them's 5 and one of them's a 7, 9. And then these are low, but they aren't 4, so they're 1, 2, 3. Oh, they're not 3 either. They're a 1, 2 pair. Okay. Just because we have the 3, 4. We have the 3, 6 and the 4, 8 here. So there's no 3 or 4 here. So this is likely low. These are both likely low, but I mean, we could do 6, 1 to get to 7 even. Even if this was 7, we could still do 2. We could do a high. We'd also do 5 on them. I'm trying to figure out what this tells us. This digit? I don't think this does anything yet. One thing we can say is whatever this is, low or high, it's also this, or a 5. We know that wherever this 5 is, we're going to have 2 lows. Either here or here we'll have 2 lows. I don't know if that's helpful. But it does mean that we've accounted for 3 of our 4 lows in this row, because we have these 2 lows, and then at least one of these is a low, because we're going to add to 5. They could both be low, but at least one of them's low. So we only get 1 more low in the row, but I don't know low in the row, but I don't know where it goes. It kind of all rhymes. That's fun. Let's see. So what does this tell us about 4s? One of the 4 is self-references. One of the 4s is here. One of the 4s is here. Okay, we know one of these is 4, right? Because the 3 is going to put a 4 there. So one of the 4s is here. One of the 4s is here. Okay, one thing, okay, what we can say, oh, that's kind of interesting. Wait, what am I saying? Because there's a relationship here, and I'm trying to figure out what it is. Okay, the 6 is going to place a 4 here, which is then going to place this 4. So if the 4 were here, we get a 4 here, and then we'd get a 4 in the 4, 8. So one of them would self-reference, and then one of them would be down here. So if the 4 is here, then there's a 4 down here. Otherwise, if the 4 is here, then we get a 4 down here. So these are not the same sum. In fact, this digit is the sum of these two, or this digit is the sum of these two, because we're going to have 4 as the other one, or maybe this digit. So we're going to have a 4 and then the sum of these two here, or we're going to have a 4 and then the sum of these two digits here, which doesn't really tell us anything. Doesn't tell me anything. Maybe it tells you something. So if the 4 is in one of these two, wait, if the 4 is in one of these two, this has to be a 9. Okay, that's progress. Sorry, I didn't see that. I marked 4 here. They both see this one. That's a 9. And then one of these is a 9. So these are not 9s. Okay. So this is a 5, 7 pair. This is not 9. We know there's a 4 on one of these. Right. One of these has to have a 4 because we're going to get an 8 in one of these. And the 8, no matter where the 8 goes, it's going to go in row 8 down here. It's going to put a 4 on it. How would we do 4 plus 4 to get 8? We can't. So this is actually 7. Okay. That's progress. So these are all from 1 to 6. That's a bit gratuitous. One of these is 3, 4. Because again, we're going to put a 4 on one of these. One of these is 3, 4, which means this is not a 3, 4 pair. We're going to have a 4 on one of these, and whichever one has the 4, the other two need to add to 3. That's going to be a 1, 2 pair. So one of these is 1, 2. And one of these is 1, 2. To go with our 4 from the 6. But the other one, I don't know. Okay, well, these add to at least 10, and these add to at least 3. That's 13. They can only add to 14. So we get 1 degree of freedom. So these are only from 1, 2, 3 and must contain a 1, which means none of these are 1s. If these aren't 1s, we found a 2, 5 pair. These aren't 1s and these aren't 2, 5. So let's fix the outsides here. The 3, 4 would go with the 3, 4, and then the 6 would go with a 1. And then these are from 1, 2, 3, 4, 5, but they have to have a 1, 2, and 3 in them. So this sees 1, 2, 3, 7, 9. So it can be the other 4, 5, I think. And it can be 6 or 8. It can't be 5 though, because it sees this 2, 5 pair. Quite limited. I'm wondering if it. Okay, so if it was 4, then this would be a 1, 2 pair. Wait, we know there's a 4. Oh, sorry, we know there's a 4 in these. I keep forgetting that. We know there's a 4. In fact, these aren't 4s because we know there's a 4 in one of these from these 6s. So if there's a 4 in one of these, there's no 5. So we end up with this pattern. This is not a 4. And then this has to be a 1, 3 pair, which means these are not 3s, which means, oops, these are not 3s, which means these are not 4s, which means these can't be the 8s, which means these can't be the 4s. Because again, the 8 would put the 4 here. Okay, this feels like really good progress. We have this 3, 8 pair here. That makes this a naked 6. Just to double check, it sees 1, 2, 3, 4. It sees 5. It sees 7. It sees 8. It sees 9. There we go. Okay, that's good progress. This is a pair. This is 8, 9. So now 8 in this column goes up here. So what can this be? 3 goes up here as well. Can this really be 8? I think it could be. It would do a lot, but it could be 8. So this is 2 digits. This is 1 or 4. We know that these aren't 4. These are 1, 2, 3. Because if they were 4, then we'd have to put a 5 in one of these. We know they're 3, 8. So we know where the 4s basically go. The 4s go here and the 4s go here. Right. So those look in. That means this has to be 4. Okay. I don't think I'm going to color low highs beyond just these German whispers. I don't think it's worth it. Oh, and the 3, 8 pair means these aren't 3. So they're actually a 1, 2 pair. And that means this is a pair. This is a 5, 7 pair. Look at all these bi values. Okay, this 2, 5 does tell us where 5s go. The 5 is one of them self-references, and one of them's over here. So one of these is a 5. I don't know that that's... Oh, and the 7 places this 5, of course. You've probably been yelling about a lot of these things, but I did find them. Just took me a little bit. This is an 8, 9 pair for this row. Let's see. These are from... Can I limit these beyond 6, 7, 8, 9? I don't know that I can. These could both be 1, right? These could both be 1. Is there any reason they couldn't be? Not that I can tell. If they were both 1, then this could be a not. This could be a 6. So, well, if one of these is 4, then it's going to go with a 5. That much we know, because it's going to be 4 plus 5 to get 9. If this was the 5, it would go here. If this was the 5, it would have to go with 1, 2. It couldn't go with 2, so it would go with... Wait, this is a 1, 3, 8 triple, now that we have this 4 placed. So this would be 6 or 8 if this were the 5. If this were the 5, this would be 5 also. Huh. I don't necessarily see that doing much right now. I'm wondering about 6 here, because it puts double 1 here. Yeah, I don't know that that's a problem. So this 3 is going to go with another 3. It's going to be 3 with a 1, 3. And then the 1 goes with a 2, 4. Just trying to make some kind of relationship out of that. So the 2, 4 is going to make this 1, 6, 4. So we'd have 1, 2, 4, 6. It's completely symmetric at this point. What's breaking the symmetry? These break the symmetry on us. So I wonder if we need to use these soon. Be nice to. I'd love to break this symmetry. Everything else is completely symmetric. So we're going to end up with bi values everywhere until we figure out how these break it. So then the other side would be 1, 3 pair, which I don't think we'd resolve, and then 2 and 6. No, 2 and 4. The 8 would make this 9. A little stuck. I'm a little stuck. Is it the indexing? Oh, the indexing here is also could be a symmetry break. Unless we end up with a 5 over here as well. No, we can't. We can't end up with 5 over here, obviously. There's a lot of reasons. There's a 5 in the box. It's the most interesting, at least interesting reason, but I feel like we can limit what these end up being by looking at how these resolve. But I don't know that that's what I'm supposed to do. It feels like a lot of work. It feels like we should resolve this first, but it kind of they affect each other. So like if this was the 5, we'd end up with 7. We'd also end up with this 4, because the 4 has to go with the 5. So we do 5, 4, 7, 6. 6 goes with 1. Be the same over here. Does it have to do with 5 in this column? Because 5, or maybe 5 in this column. Maybe it's, there is already a 5 in this column. Well, so 5 in this column, it can't be in any of these because of the corner marked 5s here. And it can't be in any of these. So either the 5 is here or the 5 is here. Oh. Yes, that's it. That's the problem. So if 5 is in one of these two, no matter where this 5 is, this can't be 5. Because we're either going to have a 5 here or a 5 here, because this clone's down there. So if 5 is in one of these two, this is not 5. And now in this box, we have only one place for 5. Wow. Now what was the reason? Yeah, and one of these has to be 5 to go with the 4. That's why we had 5 in one of these in the first place. So this ends up double 5. That ends up 4. That's huge. 4 goes with 9. Okay, we get the 7, we get the 6 going with the 1, we get the 4 going with the 3, we get the 5. 3 went with 1, if I recall. 1 went with 3. That's a 1-2 pair. 2 went with 4. Okay, yeah, that's fine. Is that does it not continue? This is 1, 2, 3 with, well, it's not going to be 1, 8. So it's either 2, 7 or 3, 6. Which means this definitely can't be 8. That's way too big. So this is either 1 plus 6 is 7, 1 plus 7 is 8, or 3 plus 6 is 9. What did I do? 3 plus 6 is 9. There we go. Oh, hold on. If this was 3 plus... Oh, these can't add to 9 because these add to 9. Oh, yeah. So no matter what, if these added to 9, we know these also add to 9, and this is the shared digit. These would be the same digit. That's cool logic. So this is never adding to 9. So this can't be 3 at all. If this was 3, it has to add to 9 or 10. So that's a 1. Nice. This has some really fun logic in it. I'm enjoying this. Thank you for this tribute to Clawdia, Lima. It looks like you put a lot of effort into it. Oh, and the 3-8 pair gives us this. This whole time we had the 1, 3, 8 triple taking the 2 out, but that was still fun logic. 2 plus 7 is 9. 7 plus 1 is 8. Okay, that's 1 and 2. That's 3 and 8. It's 3 and 1. I think I Simoned that one a little bit. 8 goes with 4. 4 places the... Oh, 4. 8 places... Oh, we had the 4 here. Yeah, there's some things I just didn't spot, but that's fine. 6 places the 4 there. There we go. So 4 with 2, 1 with 3. That's a 2 and a 1. Very nice. So these cannot be 6. These are from 7, 8, 9. So this has to be a 7 because it can't be 8 or 9. This could be 8 or 9. Oh, it can't be 8. Right. So this is a 9. There we go. Still haven't resolved this 5, 7 pair from the start. This can't be... Let's see, this also sees a 2. Okay, so this is not 6. Oh, it's clearly not 6. This is 7 or 8. This time for real. This whole box is done. We need a 6 and a 9. They go here. What do we need in this box? We need a 3, 5, 7, 8. In this box, we need a 5, 6, 7. 6 is over here. All right, I'm missing something. It's probably obvious. Oh, how about this pair? I need a 2 and I need a 6. Not resolved. Ah, but 6 is pretty high. If this was a 6, this would be 1, this would be 7. I think that's okay. What's this quad? 1, 3, 5. What did I miss? 6. This can't be 6 because it would be 6, 2, which adds to 8. You can clear out these from Sudoku. Okay, 3 can't go with 4, so 3 would have to go with 2. 6 would have to go with 1, but it can't. Okay, so this is 3 and 2. That's a 5. I don't need these colors anymore. Let's just remove them. This is a 7. That's 6 and 1. Okay, this all just resolves from that. We get the 2 down here. We get the 6. Very nice. This is a 3 now. Ooh, we get the 5 and the 2. The 2 places the 5 here. I think we're basically done. All right, I'm gonna just hit mark now to save a little bit of time. But yeah, we just get everything finished. This was a very cool puzzle. I enjoyed a lot of the logic. Some of the logic I did was probably unnecessary, but still fun. So a lot of room for creativity in the solve path, which I quite enjoy. And of course, in memory of Clawdia. Well, thank you, olima. Wow, 134 solves. Where was this posted? Very cool. Well, thank you, olima. I'm sorry I was solve 134 and not solve 1, but I rather enjoyed this. It was a fair puzzle, but also interesting, which is just the kind of puzzle I like. Especially if I'm solving it on my own and not on stream. So yeah, this was, if you want to learn more about Clawdia, you can look at my previous video. I don't know if I can handle doing that edit again, but in the previous video by Pause in honor of Clawdia, I do a slideshow of pictures of Clawdia, and at the end there's a video of Clawdia, but I don't want to put myself through that again. So this will just be a straight solve. Thank you, olima. And of course, if you enjoyed this and you want more Sudoku content or other kinds of puzzle content, word games, things like that, consider leaving a like and a subscribe and a kind comment below.